Warm greetings, everyone. So, have you ever wondered how milk turns into curd, or iron rusts, or crackers explode? These are not random changes; they are chemical reactions. So, whenever a substance changes into a new substance with new properties, we call it a chemical reaction. Okay. So, examples what I can say: burning paper, rusting iron, cooking food, everything, all kitchen cooking and everything is chemical reaction. Okay, so you can able to see this also. Vinegar, I mean, like real life demonstration. Okay, so you can add vinegar plus baking soda. Okay, it forms a gas. Gas is formed. Okay, you can able to see this. Okay, then candle is burning, right? So that is also a chemical reaction. So I can say new substance formed is equal to chemical reaction confirmed. Can you able to understand? Do you agree with me? So we represent reactions using symbols and formulas. You know, hydrogen plus oxygen, okay, it gives water. So it has the formula H2 plus O2, it gives H2. Okay. And, this has to be balanced. So that means these parts are said to be the reactant side. This is the product side, reactants, product. So it has to be balanced. The reactants and the product should be balanced. How it is balanced, we are going to see. So, according to law of conservation of mass, what is the law of conservation of mass? It is the rule. Nature follows the rule. Okay, matter is neither created nor destroyed. That means how much. What is law of conservation of mass? I told you. What is law of conservation of mass? Yeah. Matter is neither created, destroyed. Very good. So matter is neither created nor destroyed. What is the meaning? Meaning, in the react. Yeah, you can say. What is the meaning? From my perspective, matter, you're saying it's neither created nor destroyed. So I'm predicting it's either from gravity or from space because it's neither created nor destroyed. Yeah, that means, yeah, as what is said is correct. Here, according to this chemical reactions, the mass or the number of moles or the concentration of the reactants should be equal to the concentration of product because no masses entering into the chemical reactions newly or no mass is entering out of it. I mean, exiting out of it. That means it is under the rule. That means it should be balanced. Can we check whether this is balanced or not? Okay. So how many number of hydrogen, how many number of atoms in the left side, in the reactant side? Two. Two. Four. Yeah, hydrogen and oxygen. How many number of moles in the reactant side? Two, right? Hydrogen is 2, oxygen is 2. In the product side, hydrogen is 2, oxygen is 1. It's not unbalanced. It is not balanced. It is unbalanced, right? It has to be balanced. Clear up. So, what hydrogen plus oxygen, it gives H2O. How it should be balanced? You have to balance it in such a way that oxygen also has 2 electrons. Has 2 atoms. 2 atoms must be there. So put 2 in front of this. Then it makes sense. It is 2H2O means 2 moles of water, 2 molecules of water. I have a question. Yeah. Suppose, what if you can add 2 here? That's what I was going to say. I can understand. So this is hydrogen peroxide. It is not an acid. Sorry, it is not a water. It's an acid. Oxide. Oxide. Yeah, it becomes oxide. It is not a water molecule. Oh. Okay. So H2O is the water molecule. Oh. So in order to do that, we should not change the compound name. Compound. Oh. Right. The molecular formula is very important. So 2 should be added in front. Now here also it was not tallied, right? How many hydrogen is in the product now? 2. 4. Oh, 2 times 2 is. Okay. 4. So oxygen is tallied, hydrogen is not tallied. So add 2 also here.
Oh,
So this makes sense. That is 4 hydrogen and 2 oxygen, right out.
yeah.
So it is balanced now.
Mm.
This is the balanced equation. Clear?
4 hydrogen and 2 oxygen.
Yeah. It is unbalanced.
Oh.
Clear?
Can I take a screenshot?
Yeah. Obviously. So like this, I will explain you about all these things. I'm giving you an introduction. I'm explaining you all these things in a proper way. So we are going to add on all these things in the subsequent portions. Okay. Now, in this lesson, very interesting topic you are going to see. So lot of activities are given. So that also we'll see. So before that, I will give you this types of reactions. Okay. So what all in this lesson you are going to learn about the chemical reaction. That means there are activities given. So many activities, and based on the activities, some questions are asked. That will also we'll see. Okay. To my students, I have sent all the answers or solutions for those questions, which is, which is mentioned in the activity side. Okay. Activity 1.1, 2, 3, like that, it goes on. So we'll see that also. So right now, you must know what are all in this portions. You know, right? So what is a chemical reaction? What are all the chemical reactions associated in our daily life, real life, right? So everything we saw. And then if it is a chemical reaction, definitely new product should be formed. If the reactions are there, then only it is a chemical reaction. And also we saw balancing, how to balance the chemical reactions. Why balancing is important? Because it should follow the law of conservation of mass, right? So it should be balanced. Right now, to the next step, we will see types of reactions. What are all the types of reactions we are going to see? I will give you a very, very clarified outline so that we'll get into the lesson very easily. Okay. So first one is combination reaction. What is it called?
Combination.
Combination reaction.
Yeah, write this down or?
Yeah, you can write. So that means if A and B is the reactant, okay, AB is the product. It is combined, okay?
Oh, okay.
So reactants, this is product. Clear? Decomposition reaction. Next one is decomposition reaction.
It's separate.
Yeah, that's it. The vice versa, the reverse of this. That is decomposition reaction. Decomposition reaction. Now this becomes reactant. AB becomes reactant. A plus B becomes products. Then displacement reaction.
What? They swap?
Yeah. One is displaced by the other.
Oh, they swap or?
Not a swap. I will explain you. Displacement reaction. See right now, for example, A plus BC. It gives AC plus B. It gets displaced to be here.
Oh, so basically that's swapping them.
Swapping means both the things, double displacement is swapping.
Oh,
It is displacement simply. Next, we'll see double displacement. That is swap. So what is double displacement reaction? AB plus
C.
Ah.
Then a CD, so that swaps. So
Yeah.
swaps with AB.
Yeah. Or AD plus BC or AD plus BC. Both are okay.
Oh.
Can you able to understand this? Then redox reaction also you have learned. Redox. Redox. That means reduction, both reduction and oxidation. Okay? Oxidation plus reduction together. I will explain you all these stuffs. Okay? Clear?
Oh.
So this is very important. So chemistry is not just formulas.
Yes.
It is the language of transformation in nature, we can say. So chemistry is very important. Okay. So, food cooking is also a chemistry. I told you, know.
Yeah.
In our human body, digestion takes place. That is also a chemistry. Okay. Burning of calories, that is also a chemistry.
Mm.
Burning anything is also a chemistry.
Mm.
Okay, so what are all the signs of reaction we can able to say?
Mm.
If the chemical reaction takes place, what are all the signs of reaction? Sign, I'm saying SIGN. Signs can be seen. Signs can be seen.
Mm.
Color change, right?
Yeah.
There must be color change.
Yeah, broken.
Then gas formation.
Okay.
Gas is formed. Then temperature change.
Mm.
Temperature
Mass.
change. Like
Mass.
mass will not change, right?
Oh, yeah. Okay.
It has to be balanced. Then precipitate formation.
Oh.
When the food is cooked, definitely it is hot, right?
Mm.
After some time, its hotness will settle.
Mm.
Then precipitate formation. Precipitate formation means if you mix up something and then kept it for some time, definitely the hardest particle will go under.
Yeah.
Yeah. So that is the precipitation. So how many precipitation you can able to see? Okay. Clear? Hello? Is it clear for you? Aryan? So these are all the signs of the chemical reaction: color change, gas formation, temperature change, precipitate formation, everything. Okay, clear or not?
Mm.
So you can able to write the reactions and everything. Okay, I will explain you about the reactions. Okay, so we are going to see about all the reactions. Okay, using symbols and formulas.
Mm.
Clear? What is the law used here?
Law of conservation of mass.
Very good. So law of conservation of mass. First, we'll write the skeletal equation, unbalanced equation, and we are going to count the atoms and then balance one by one, and then verify whether it is okay or not. Okay. So we'll see all these stuffs. This is chemical equation. This is first equation. It shows it activity 1.1. It shows like that, right? What is this? Magnesium ribbon.
Mm.
So it can be done in a chemical lab
Mm.
under the observation of the teachers, not by the students alone. It is not advisable.
Mm.
Suppose from the 3 activities, what are the 3 activities? Here, what is first activity given? This activity needs, okay. So clean a magnesium ribbon about 3 to 4 centimeter long by rubbing it with sandpaper. Okay, hold it with a pair of tongs. Burn it using, pair of tongs means this is pair of tongue. Right? In our kitchen also we are using.
Yeah. Okay.
So before that, it will be like this. So initially, your mom is using this kind of pair of tongs.
Oh.
Okay, done. So this is pair of tongue.
Mm.
Like we can handle the magnesium ribbon.
Mm.
Okay, burn it using a spirit lamp. This is the lamp, spirit lamp.
Mm.
Okay, and then or burner we can say. And collect the ash in a watch glass. This is a watch glass. Here the magnesium ribbon is, see, this is how you can able to see this. This is magnesium ribbon. Now ashes are fallen to this watch glass. This is the burner. Okay. And then here it is the tong. By using the tong, the ribbon is okay. Handled and burn the magnesium ribbon, keeping it away as far as possible from your eyes. So what do you observe? That is the question. Okay. So what is the observation? Burning of a clean magnesium ribbon, okay, with a dazzling white flame to form white color powder. Magnesium oxide is formed.
What if the flame is just normal, not a white flame?
Huh?
What if the flame is just normal?
Yeah, normal flame only, but the powder is like a white ash.
Oh, powder. Okay.
Yeah. White color ash kind of powder. This powder that is magnesium oxide.
Okay.
Okay, it is the white powder, white color powder. Okay. Say, and then again take a lead nitrate, right?
Yeah.
Lead nitrate, PbNO3,
Oh.
NO3 twice, like that. Okay, so PbNO3 twice in a test tube. So like this.
Mm. Oh.
So test tube is like this. It is a test tube. You have seen this, right? It is a test tube.
Mm.
Add potassium iodide solution to this.
Mm.
What do you observe? That is the question. Okay. If lead nitrate uh, solution is mixed up with potassium iodide solution,
Mm.
then definitely yellow precipitate is formed. What is that?
Yellow precipitate.
Yeah, yellow precipitate of lead iodide.
Ah.
See, lead nitrate plus potassium iodide, Ki.
Oh.
Okay, now what will happen? Lead iodide is formed, PbI.
Oh.
Got it.
Okay.
Okay, so this is actually because what is that? It is a yellow precipitate. Yellow color precipitate is formed. It's deposited at the bottom.
Mm.
Lead iodide is precipitated as. So this reaction in a molecular formula we are going to learn further.
Mm.
Right now you can learn all the activities. Okay.
Oh.
So then I told you, these are all the signs. Temperature may change, state change means liquid to gas, gas to liquid, solid, like that.
Mm.
Change in color,
Mm.
Here you can see yellow precipitate.
Mm.
Okay, then gas also may evolve. Okay.
Mm.
Then what is the third activity? It's shown.
Mm.
This is the conical flask.
Okay.
Okay. So always in chemical lab, handle the flask with care, handle the acid with care. This is very important. Okay. So right now, take a few zinc granules in a conical flask
Mm.
or a test tube. Add dilute HCl. That's what this is, a hydrochloric acid.
Mm.
Dilute HCl gas. Clear?
Mm.
Then what will happen?
Mm.
So dilute HCl gas is added. Okay. And what it is given? Okay. Handle the. Okay. Do you observe anything happening around the zinc granules? That is the question.
Oh.
HCl acid is added.
Mm.
Okay. Dilute sulfuric acid on zinc. It shows.
Okay.
Okay. Sulfuric acid or hydrochloric acid, both. Okay. HCl or H2SO4, both you can add anything. Okay. Then what will happen? So that is the question. What will happen to the granules? Okay. So you can see bubbles are observed.
Mm.
See, bubbles are observed around the granules due to the release of hydrogen.
Mm.
Hydrogen is released. Okay. So touch the conical flask or test tube. Is there any change in its temperature? Definitely
Yeah.
there will be a change, right? It becomes, the conical flask becomes hot. So hot means it is an exothermic, right?
Mm.
During reaction, the heat is evolved
Mm.
so that the flask is hot.
Mm.
So endothermic means heat is absorbed by the
Yeah.
material. Okay. Can you able to understand this?
Mm.
So it is definitely hot. Okay, that is a heat change also. Okay. Like this, you have to learn the activity
Mm.
and try to answer for this question.
Okay.
Okay, so the question is here. Clear?
Mm.
See, for example, the first activity we saw, right?
Mm.
Magnesium plus oxygen, it gives magnesium oxide.
Mm.
So this is the statement, skeleton. Like from the statement, you can write the skeleton. Mg plus oxygen, it gives MgO. And then you have to tally.
Oh.
There are 2 oxygen here. So put 2. So 2 Mg plus O2, it gives 2 MgO, magnesium oxide. Okay.
Okay.
It is not tallied, right? It is not unbalanced, right? So we have to balance by means of this.
Mm.
Okay, so this is the balancing equation, you know. Then the next activity, third activity, it shows zinc plus sulfuric acid, right? It gives zinc sulfate plus hydrogen. Hydrogen gas is evolved.
Mm.
So hydrogen gas is, evolved, like, so gas symbol you have to put. Zn plus H2SO4, it gives ZnSO4 plus H2, zinc sulfate plus H2. How you can tally this equation?
Mm.
See, first of all, this is the reactant side.
Mm.
What are all the atoms in the reactant side? Zinc,
Zinc, hydrogen, and
sulfur,
sulfur.
oxygen, right?
Mm.
It is the reactant side. Reactant side, how much? Zinc? 1.
One.
Hydrogen is 2.
Two.
Sulfur is 1. Oxygen is 4, right?
Yeah.
Then you have to check with the right side. Zinc is 1, correct. Then sulfur is 1, correct. Oxygen is 4, correct. Then hydrogen is 2, correct. Right? It is tallied. Clear? Can you check now about whether it is tallied or not?
Okay.
Like this, put a table. Hmm?
Okay.
What are all the element?
First is what is that?
Iron.
Iron, water, iron and water,
And oxygen.
and oxygen.
Reactant side, product side.
And then reactants in the left-hand side.
Uh,
There's one iron, one oxygen, sorry, one hydrogen and two oxygen. Sorry, two hydrogen and one oxygen. In the right-hand side, there's 3 iron, 4 oxygen, and then 2 hydrogen.
Okay, is it tallied?
No.
So you have to tally this, right?
Mm.
There are 3 iron,
Mhm.
right? How come we can able to tally this? Then oxygen also 4 oxygen.
Yeah.
So we have to tally like this. See?
Mm.
So what is the step 3 we have to do?
Mm.
Atoms of oxygen first we can tally.
Okay.
Because it shows it is often convenient to start balancing with the compound that contains the maximum number of atoms. So oxygen is maximum number of atoms. We can tally that first. It may be a reactant or a product.
Okay.
Okay. Is it clear for you? That is the first clue. You have written like this, right?
Mm.
This table you can able to do, right?
Mm.
Once the equation is given. Okay. After that, what is the step 3? You have to choose which element is having more number of atoms.
Okay, that's
Whether it is in reactant or product. Okay, that is the third step. Select the element which has the maximum number of atoms.
Mm.
Clear? Using these criteria, we select Fe34 and the element oxygen in it.
Mm.
So there are 4 oxygen atoms on the RHS and only 1 on the LHS.
Mm.
So initial to balance. So initial, what is that? In the reactants, only 1 oxygen.
Mm.
In the product, it is 4.
Mm.
Right? So you have to balance 1 into 4 here. Right? So put 4 before. So 4 H2O. Now hydrogen also 8, right? 4 H2. Oxygen is tallied. So you have to put 4 here.
Isn't it 6?
4 2s are like that only you have to do.
Okay.
Okay. Is it clear?
Mm.
Then iron is not balanced, right?
Mm.
Okay. So how can you balance the iron?
You add 3 Fe. There.
So Fe here, Fe3 is here. So you have to add 3 Fe.
3 Fe plus 4 H2O
Yeah.
equals Fe3O4.
Yeah.
Then it's balanced.
Plus 4 H2.
Then it's balanced.
Yeah. Then it is balanced. Is it clear for you?
Mm.
Okay. Then writing symbols of physical states, carefully examine the above balanced equation. Does this equation tell us anything about the physical state of each reactant or product? No, right?
No.
That's what. We had to mention this also.
Mm.
Ferrous is solid, water is here, the water is gas or liquid. Then here, ferric oxide, right? So this is oxide group. So it is also solid.
Mm.
Ferrous oxide or ferric oxide, these are all the solids. Then this is gas. 4H2 is gas.
Mm.
Because gas is deposited, right?
Mm.
Gas always collected from the upward displacement. Gas is moving upward only, right? Precipitate is collected as the downward displacement. Okay?
The color and stuff?
No, precipitate. The sediments.
Oh, the water vapor.
Yeah, we saw that yellow precipitate of lead iodide.
Yeah.
That if you want to collect the lead iodide, that lead iodide has to be collected as a downward displacement because it is deposited as a precipitate underneath.
Okay.
Gas means it is moving up only. So it is upward collection. It has to be downloaded, or we can say it has to be displaced in a upward motion.
Okay.
Okay. So physical states also very important. We have to address all the elements based on physical states. Can you able to understand this? See this reaction, CO in gaseous state plus 2H2 in gaseous state at 340 atmospheric pressure. ATM means atmospheric pressure. It gives CH3OH. It is liquid.
Okay.
Okay. Same way 6CO2 aqueous. Aqueous means anytime it may be converted into an ion.
Oh.
That is aqueous. Okay. Converted into an ion means, C plus and O2 minus, like that it may. Okay. So it may be converted into an ions like that. Okay. So it is aqueous. Then it is liquid. So sometimes the water might be liquid, water might be gaseous state, vapor. Water vapor is gaseous. Water may be in a solid state also in the form of ice, right? So sunlight, and then in the presence of sunlight, chlorophyll pigment.
Is this
Yeah, exactly. It has happened in plant, right? It produced its own sugar, that is glucose. It is an aqueous state. 6CO2 also aqueous state. H2O, 6H2O liquid state. Okay, you have to balance these two equations step by step. You know how to balance it, right? Take it as a homework, children. Okay, so I want to show this into a. Then we saw these types of reaction, right? What are all the types of reactions we saw? Combination.
A combination reaction.
I taught you like A plus B equal to AB. So for that, it gives quicklime, calcium oxide in solid state plus water in liquid state, it gives slaked lime. CaOH twice in aqueous state plus heat. Heat is evolved means it is exothermic. Okay, if you see heat in the product side, it is exo. If you see heat in the reactant side, that is endo.
Okay.
So heat is absorbed means heat should be added in the reactant side.
Okay.
Heat is evolved means heat should be added in the product side.
Okay.
So formation of slaked lime by the reaction of calcium oxide with water. This is the combination reaction. Okay. It is actually used for the purpose of painting and everything. Okay. The slaked lime is a kind of paint, we can say. Then this is the example for combination reaction. This is also an example. Carbon in solid form and oxygen in gaseous form, it produces CO2. Carbon dioxide in gaseous form. This is burning of coal. It is also an example for combination reaction. So, H2 plus O2, it gives, I taught you with an example. It gives H2O. So, this is also an example for combination reaction. Clear? So these are all the example for combination reaction. Okay. Then burning of natural gas, it shows it is an exothermic chemical reactions. See, methane plus oxygen, it gives CO2 plus 2H2O. Okay. Exothermic process, respiration also an exothermic process, right? Respiration.
Okay.
We get this energy from the food we eat, right? We need energy to stay alive. During digestion, food is broken into smaller substances, right?
Yeah.
So you know all the stuffs. And then it provides glucose, right? Mainly it is glucose, it provides energy for us. Then the special name of this reaction is respiration. The process is this one, glucose, right? Plus 6O2, it gives 6CO2 plus 6H2O plus energy. So this is the energy we require.
Oh.
So then decomposition of vegetable matter into compost is also an example of exothermic reaction. So if the vegetable waste is put it in the ground,
okay,
then it is decomposed, and then it forms like a organic manure. So it is an exothermic reaction. Okay. Then this is basically decomposition reaction.
Mm.
So what is the decomposition reaction? So one product, AB,
Mm.
it gives A plus B. It is splitted into two or more reactants, products we can say. Okay, a full reactant, one full reactant it is decomposed into two or more products.
Mm.
Okay, here you can say Fe2SO4, so ferrous sulfate,
Mm.
FeSO4.
Mm.
It is solid form. In the presence of heat, this is endothermic.
Oh.
In the presence of heat, right?
Mm. Yeah. Endothermic.
Endothermic. So it gives Fe2O3 solid.
Mm.
Sulfur is okay. Sulfur evolved like sulfur dioxide and sulfur trioxide.
Oh.
This from this also you have to balance.
What's the difference between dioxide and trioxide?
O2 means di.
No more.
O3 means tri.
No, what are the differences between them?
It is different compound. Sulfur dioxide has different property with sulfur trioxide.
Mm.
Okay. Is it clear? Okay, ferric oxide, it is ferrous sulfate, like that it will be.
Oh.
Can you able to understand this? So ferric oxide is a solid.
Mm.
Hmm?